This talk is going to be more about infant perception than about infant conscious perception, but I will say something about consciousness somewhere in the talk. But I think these issues are they're closely tied. Okay, so starting with adults, many of you may be familiar with this really cool set of experiments by Michael Cohen, where people look at pictures, which in the raw form look like this, but then they're wearing an eye tracker, and wherever they look, that's in color, but the rest of it isn't. And the amazing result is people tend not to notice that bleeding out of color. So this raises the question, well, why? And there are two answers. One is, and this is generally true for all these change blindness things, there's these two answers. One is people aren't really seeing the color in the periphery. That's sparse perception. More specifically, we have, as Michael Cohen likes to say, we have vague, gisty, ensemble visual representations that don't distinguish between color and no color in the places where you're not actually attending. The other option is we fail to apply color concepts. We don't cognitively register the difference between color and no color, and so we don't notice it in a cognitive sense. And so no alarm bells go off because those alarm bells are tied to cognition. I favor the sparse cognition view, but of course, we're not talking about exactly this today, but here's what I want to do. I want to compare this case with something about infant color perception. So basically what I think is there's a parallel in these two cases that the parallel is I claim subjects don't distinguish these because they don't apply color concepts. And I claim in the case of infants, there are infants between 6 and 11 months who see color, but don't normally cognitively register color differences because they don't apply the color concept. So that's the similarity that I want to draw. Now, there are two possible reasons why they don't apply the color concepts. One is they have the concepts but don't apply them. The other is they don't have the concepts. Now, I favor the second, that they don't have the concepts, but this difference is not going to be important. So that's what that says. I should say that they don't normally apply them. I'll mention some circumstances, and there are other circumstances that I'm not going to go into, in which they do apply color concepts, but they're rare and peculiar. And the idea is that normally they don't reason with color. So they see color, but do not normally reason with color. So there are three stages in representation of color. By 4 to 6 months, they have color category representations, and I'll say what those are. By 11 months, they have the beginnings of color concepts, and it takes another 2 years before they get linguistic color concepts. So this, I'll say something about this, why this is so incredibly difficult, but it just shows something about the great difficulty that infants have with color. So my claim is that in this period, they have between 6 months and 11 months, they have color perception normally without color concepts. Although, as I said, there can be peculiar cases. So I got these pictures off the web. These are supposed to be actual children of these ages, but it's that intermediate age. So that is going on here. So just to remind you about categorical perception, we all really know, because we've seen rainbows, that we have categorical perception of color. So the rainbow is a continuous band of wavelengths, but we see it as stripes, right? And that is categorical perception. The behavioral indication is faster and more accurate discrimination between categories than within categories. So if you have a red and a yellow differing by a certain amount, and then two reds differing by the same amount, the two reds look more similar and you categorize them as the same color. Now, there have been fantastic experiments on infants' color vision by Anna Franklin at the University of Sussex. And she has a number of different ways of measuring infant color perception and infant color categories. So it's really cool work. But the simplest method is they have a screen of one color with a disk of what we see as a different color. If the infant sees it as a different color, they just move their eyes to it, and you would do the same. So all humans do that, I mean, with some degree of regularity. And if they move, you can use this method to gauge their color categories, because if the background and the disk are of different categories, you move your eyes faster, okay? And you can use that to map out the color categories. The color categories can also be mapped out by other methods which agree with this method. So it's a really cool case of different behavioral tests that converge. They needn't to have converged, but they do converge, making you much more confident that this thing is real. So this is one a test. This is habituation. The kids see the same thing on left and right, same color, same color, same color. They lose interest. They start looking at their feet, and then a different color pops up, and you can use the measures of how long it takes them to lose interest in that as an indication of whether those are different color categories, and it's a novelty preference. Different methods yield the same color categories. There are 5 categories in infants cross-culturally, and I'm not going to say any more about it. So do they attend to color or notice color? Well, they certainly show attention, but it's cognitive registration that is the issue. Okay, so I've just talked. I'm going fast because I don't have much time. So that was all about the perception of color. Now I'm going to turn to the cognition of color, and I'm going to argue that despite adult level color perception by 4 to 6 months and color categories, the infants do not normally cognitively register color. Here is a great experiment. In this experiment, you can have same shape of different colors, and there's a rule which the infant learns, which is if you have 2 things of the same shape, then some really cool thing will happen on one side or the other, and the infant will learn that rule, as shown by the fact the infant will look to the side with the cool thing happening, jumping frog making wonderful sounds. But the 12 months old can learn this one, but they're just beginning to learn this one, the same color on the top. So they have a lot of trouble until 11 to 12 months learning a rule, same color, look left, okay? So that is an example of how they can do a cognitive task with shape, but not with color. Okay, so below 11 months, they can't do that. Of course, this requires some kind of appreciation of sameness of color, cognitive appreciation. Here is a different paradigm that Susan has pioneered. You have a thing of one color come out from one side of the screen, and then the relevant question is, do they expect 2 things? And under 12 months, they don't expect 2 things. So they don't cognitively register the color difference in a way that allows them to reason with it. So they use shape and also kind information in forming expectations months earlier than they normally use color. Here's another paradigm. This is Tremblay, Leslie, and Hall, where what you have, I'll just focus, this is the control. you have something of one shape coming out and going back, another shape going out and going back, and then the screen comes up, and you can have an expected result or an unexpected result. They're not surprised, under 12 months, they're not surprised by um, uh, uh, two things. If you have a red thing going out and going back and a green thing going out and going back, and then you have two red things, they're not surprised. Um, so uh, I'm talking, I'm really giving a very quick rendition of a chapter of this book, which is available free download on the OUP site. And this is chapter 6. And one of the issues I discuss is salience. So this is something that immediately comes to mind. And what I say is, the results just described involve a contrast between color on the one hand and shape and kind on the other. Perhaps color just isn't as salient as shape and kind. Perhaps, but that isn't an objection. Rather, if true, it may provide an explanation of why the infants normally lack color concepts and have such stark cases of non-conceptual perception. So I now think that the perhaps is wrong, that definitely salience is involved here, but salience is very closely tied with the lack of concepts. I don't know quite which way the causation goes, but so here is another. Moving right along, here is another kind of experiment. So this is something, a phenomenon called the tunnel effect. So you have a very narrow screen, only slightly wider than an object, and you have a green ball that rolls to the screen, goes behind it, and then either a green ball or a red ball or some other color ball emerges. And then the question is, does the child look longer at the impossible thing? And what you find is, the result here is that 4.5-month-olds show increased looking time compared to a wide screen. They compare with it takes a narrow screen for this tunnel effect to work, but not if a red ball turns into a green ball. Still, at 7.5 months, they're not using color, and it isn't until 11.5 months that they use color. Now, this is an important case because it raises the question of whether the infants have a color concept that isn't activated. And some evidence for that is that the same Wilcox and colleagues found that you could train the babies to notice color. And the way they did that was, so just training them 9.5 months old, look longer at a red ball changing to a green ball. But even with 3 rounds of training, it took 3 rounds of training for a 7.5-month-old to do it. And the 7.5-month-old didn't transfer from red, green to blue, yellow. So it looks like the 7.5-month-olds aren't really noticing color per se, but there's only specific colors. I'm going to skip that. So here's the way that they trained them. They used different color cups to do different things. So one color might be used to pound, and another color might be used to pour. So with repeated examples of using the different color things to do different things, then the kids started to react to the change of color. I just said that. Okay, so now here is an interesting question. Does training change a perceptual representation into a conceptual representation, or does it activate a present but inactive concept? So a conceptual representation is one that has a certain role in reasoning, thinking, and other cognitive processes. We can call that the R role. And so we might raise the question, does training give a perceptual representation the R role, or does it activate an inactive R role? So what is the R role? One thing the R role does is learning rules like this: same color predicts something. I prefer this. It gives a perceptual representation, the R role, because I don't see any reason to think there are these schemas like same color, look left, just hanging around. These features of the R role what is the likelihood that they're just hanging around waiting to be activated? So, all right. So moving on. How much more time do I have? Okay, yeah. Um, okay, so what about the possibility that infants have a concept of color as a temporary property of things? Well, this is a cool experiment that explores this. So 6 to 8 month olds prefer to look at these normal colored things um, rather than these odd colored things. And one might speculate that these odd colored things look weird to the kids as well as weird to us. Um, okay, so below 12, so just to summarize, below 12 months, babies don't normally use color concepts and reasoning except with special stimuli and special training. Um, and here is this really amazing thing. The beginnings of color concepts start at 11 to 12 months. Um, and at 24 months, they can use a year later, they can use color to distinguish, your toy, my toy, because mine is this color and yours is that color. It isn't until um, 3 years old that they know the four basic color words. I should say that this is probably decreasing. Binet's early IQ tests from the beginning of the 20th century showed that children did not, in his sample, did not have the four basic color words until they were 7. Okay. Now, of course, the kids are earlier. And why, you might ask, well, why are they earlier? Well, come on, you look at plastic. I mean, these kids are bombarded with plastic things of many different colors. So uh, in 1980, Mabel Rice did this teaching experiment. She took a group of 2 to 3 year olds who didn't know any color words and taught them the difference between red and green. And what she found was for most of these children, learning this difference took over 1,000 trials over several weeks. And, parents have long noticed that their kids have words for other things, and they surprisingly lack the words for the color words. There was a Scientific American article which went into great detail about this, quoting a lot of parents. And the odd thing is the parents think the kids know the color words, but they don't. The kids have memorized some color names for various things, but they don't actually know what the words mean. So parents are often highly misled about the color terminology of their children, and this was very nicely not the misled part by Charles Darwin, who said, I attended carefully to the mental development of my young children, and with 2, or as I believe 3 of them, soon after they had come to the age when they knew the names of all common objects, I was startled by observing that they seemed quite incapable of affixing the right names to the colors in colored engravings, though I tried repeatedly to teach them. I distinctly remember declaring that they were color blind. And in the German literature, there's a term for this, Farbendummheit, color stupidity. Uh, so anyway, just to summarize, kids between 6 months and 11 months, they see color, they have perceptual color categories, but they do not normally have concepts of color, and that shows that it's possible to see color without cognitively registering it. And so getting back to the sparse perception fallacy, um, uh, uh, so the fact that subjects do not cognitively register a difference doesn't show that there is a difference in the way things look. So the alternative explanation is they do not apply the relevant color concepts. And I think the same story can be told about this case, that they don't distinguish these because they don't apply color concepts. See, this is about consciousness, because this has been a major, this idea of sparse perception has been a major motivation for cognitive theories of consciousness. So as I'm sure everybody realizes, there's been a controversy, recently between the sensory theories of consciousness, like the recurrent processing theory (IIT), versus the cognitive theories of consciousness, global workspace and higher order, and the cognitive theories of consciousness typically come to the conclusion that perception is sparse. And the reason for that is that cognition is sparse. The global workspace says we can cognize maybe one or two or three things at a time. That we're very limited in our higher order thoughts or higher order pointers. So those views all come out on the side of sparse perception, whereas the sensory theories come out on the side of rich perception. So this was a talk advocating the rich perception point of view in a sneaky way. So there it is, and the end.
So, hi Ned, thank you very much. Lovely talk.
In a longer version of this, I used some of your stimuli.
So I had, I guess, 2 points I'd like to make and like to hear you think about, both relating to cerebral achromatopsia. So an absence of color experience caused by acquired, people I look at, brain damage acquired in ventromedial occipital cortex. And so the first question is a question about, perhaps what the nature of infant color consciousness might be. So our cerebral achromatopsic can use differences in the wavelength distribution of light reaching his eyes to segment a visual scene into figures and background. So if we present a red circle against a green background and ask him what he sees a disc, but he can't tell us anything about the difference between the color of the disc and the color of the background. So you've got a situation where you're processing chromatic edges, and you can do that with striate cortex, but you can't then, from that earlier position, you can't then generate and identify the colors of surfaces. And so I just wondered if that was a plausible explanation of what infants are doing. And then a slight follow-up to that. I once, it must be like 20 years ago, tested a guy who was a hemiachromatopsic. So he had damage to fusiform and lingual gyri, ventromedial occipital cortex on one side of the brain, but everything fine and dandy on the other side. And so what you would expect is that he'd have color vision in one visual field and no color vision in the other visual field. He certainly didn't report that, but the anatomy looked right. And he was a bit difficult to test, so I had to do, cheap and cheerful bedside testing. So stare into my eyes and now tell me what color the pen top is. And on the side, in the visual field, which was normal, where there was no brain damage, I could have the pen somewhere out here and he'd tell me what color it was. In the affected visual field, I had to bring the pen right into central vision. But he had no idea that he had no color vision in one hemifield. He was really shocked at this result. But of course, he did have perfectly good color concepts because he had color vision in his good visual field. So he was perfectly capable of, I guess, representing the different colors that potentially were present in his affected field. But first of all, he didn't do that. And second, his failure to do that didn't then result in him actually noticing that there's a difference in experience. And so that seems to me slightly at odds with your position. Sorry if that was a bit long and rambling.
I'm not sure why it's at odds with my position. I mean, I don't know what to make of that case. Maybe it's anosognosia, maybe it's some kind of filling in or something? What did he say when you had it, in a chromatopsic field, but before you'd gotten to the point where you could identify the color? What did he say the color was?
He just couldn't make a decision. He was just.
But what did he say it looked like?
Uncertain. I can't tell. I can't tell. Why can't I tell? So he wasn't.
Sounds like anosognosia to me, because what is that experience of can't tell?
Yeah, but we know, we have very good reason to believe that he wasn't having a color experience.
Yeah, but anosognosia would be no color experience, but a failure to recognize that fact.
Yeah, yeah. Anyway,
but the first point you made is I'm more worried about that, because all the paradigms, all the Anna Franklin paradigms involve differences. Do you move your eyes to a disk of a different color? Do you habituate? What?
But the habituation involves the memory of the differences, so it can't be that.
Yeah, so it can't be that. That's right. Yeah, yeah.
One that they register a difference.
Yeah, that's true. It's a yeah.
That's the reason she did it, change.
Yeah. Okay. Yeah. Right. So maybe that does answer that. Yeah. Hi, Barbara.
Hi. I was wondering how you distinguish between not having the color concept and it just being more difficult to do some of these tasks. That's not quite salience, but I was thinking, maybe for adults, if they were to see, it would be more difficult. They'd be slower at maybe identifying different colors than different shapes. I was thinking I'd probably be slower at doing that. Yet I have color concepts. So yeah.
All I can say is that a variety of experimental paradigms do not reveal any ability to use color in reasoning or forming expectations. Now, it's possible that making everything slower would help, but I don't know if anybody's tried that. What about in your paradigm? Have you tried making everything really slow? No. So I don't know.
But they have the concept. It's difficult, so they can't do it.
Okay, that is the kind of intuition that should lead to an experiment if you really have some force behind that intuition. Somebody has to take it seriously enough to do the experiment.
Yeah, thank you for a great talk, Ned. Okay, so this is a population-based question, and I just want to hear your thoughts about it. So after a 3-year pediatric residency, I did a 2-year.
Wait a minute, what?
After a 3-year pediatric residency here in New York, starting here right at NYU 40 years ago, I did a 2-year fellowship in developmental pediatrics. And every pediatrician knew about the Denver Developmental Screening Test, which was based on a couple of thousand, 2,000 or 3,000 kids. Actually, it was done twice, Baltimore and Denver. There was a Denver 1 and Denver 2. And they looked at screening for children based on thousands of children. The one I struggled with the most was color and naming 4 colors, identifying 4 colors. And
how old were the kids?
Well, it goes from birth to 5, and there are different levels of developmental screening in terms of motor, cognitive, play, language. And one of the, 25 items on this developmental test, which all pediatricians administer to all children as a screening test, not an IQ test, but a screening test, was this identifying 4 colors. So I became a parent while I was doing that, and I tested this on my own children, and my kids are bilingual, and they could identify 8 colors in 2 languages at age 2. And on this bar, 25% of kids could do that at age 2. But of all of the developmental milestones, the color, identifying 4 colors, was the one that baffled me the most. I could never figure it out, because on the 90% of kids, they give you 25%, and when 90% of kids can do it. And the 90 percentile was 4.5. So of all the developmental milestones on that developmental screening test, recognizing 4 colors and naming them was the broadest. And so I think my kids went to graduate school. I think they're smart kids and things like that. But that was the norm for me at home. But I could never figure out, who are these kids? Now, 8% of boys are colorblind. Well, they can only see blue. That's an X chromosome genetic condition. And it's not for that reason that at least 10% of kids at 4.5 can't do that. And I don't think it's because of an intellectual disability either. But anyway, this was the milestone that pediatricians screen for that had the broadest variability. And personally, I've thought about it for the last 40 years. I could never figure it out. What is your thought? And I don't know that I listened to your talk very carefully. I don't know that you answered that for me.
No, I did not. And I mean, I can speculate, but I'm interested in that. And if I would love to see some papers on this Danvers test, if you could send me a reference or something. But look, here's my speculation. My speculation is kids do not usually notice color. But there are various things that can be done to get them to notice color, like that training thing that I mentioned. So I'm guessing that some kids, for whatever reason, notice color early on, and others kids just need to have it. You know, Mabel Rice, 1,000 trials over several weeks. Other kids have to have it, knocked into them. And I don't know what the relevant variable is here for why some kids get it. It may just be random chance. Did you happen to notice this in a circumstance in which it led to something? You know, you tend to see in the developmental literature that I looked at, you do tend to see averages, and they don't tell you that, they're not that interested in individual differences. But I'm sure there is a lot of work on this.
That's a tough act to follow, so I'll do my best. This has been a great conference. I've been learning a lot at it, and I've been really privileged to be here, and it's really cool. I come at this from thinking more about theories of consciousness than specifically about infants. So my question is, what would you want to say about the kinds of results that Ned is talking about from the higher order perspective? And since that's my job, I do want to start off with a disclaimer, which is that I do think that higher order theories are empirically false, if they're false at all. So what I mean by saying that is I'm not really a true it's a thinker, guys. It's a thinker. I'm not a true convert of the theory. I don't think that it enjoys a special status or that it should be thought of as ahead of other certain theories. I think of it as one of a class of theories that has just got to the point where you could develop it in enough detail that you could start to see what kind of empirical predictions that it would make. And what we want to do with all of these kinds of theories is develop them in the detail that would allow us to see whether they are empirically refuted or not. And so for that reason, I do really want to highlight and emphasize that Ned's kind of insistent and relentless challenges against these kinds of theories is much appreciated, because I do think that these are the right kinds of theories. Okay, so we just heard Ned's case, and I'm not gonna repeat the case that he makes here, but it is an interesting experience to be reading his book, because you're reading along and you get to chapter 6 and you're thinking to yourself, this is very good, very interesting. And then by the time you get to chapter 13, he suddenly says, and therefore cognitive theories of consciousness are wrong. And it's really that part of the argument that I want to challenge. So that I think that really what he does is highlight some need for further empirical work, but also a way to differentiate certain kinds of theories. So I think that we get two challenges from Ned's work. The first is just, do these infants have phenomenally conscious color experiences? And the second is, if they do, are these non-conceptual in the sense defined by Ned, where to have a non-conceptual color experience is roughly to have the experience, but not have the concepts that you would need in order to specify the experience. So it's those two challenges I think that we want to address. And I do think that higher order theories can escape unscathed here. I do think that different versions of the theory will respond in different ways, but I don't think that we have anything that amounts to a refutation of these kinds of theories. We have something that points to areas where we would like to see more thinking being done and more work being done. Okay, so that's going to be my general argumentative strategy. What is it that I mean by a higher order theory? Surprisingly enough, even here you'll find some controversy. People mean different things by higher order theories. As I use the term higher order, a theory of consciousness is a higher order theory when it sees a special role for inner awareness in the explanation for phenomenal consciousness. So if you want to say what phenomenal consciousness is, then higher order theories are just those theories that say part of the explanation or account of phenomenal consciousness involves a kind of inner awareness, where inner awareness here means an awareness of one's own mind or mental functioning. So by that reading, first order theories are simply theories that don't see a role for any kind of inner awareness in an account of phenomenal consciousness. So global workspace theory, IIT, local recurrency, and these other theories that we find often on the market are all versions of first order theories as I understand things, because at least as they're put forward now, they don't see a role for inner awareness. You could easily think of versions that do see a role for inner awareness. Some people have actually tried to defend versions of like global workspace theory that sees it as a kind of inner awareness. So there's a lot of debates there. My point is just that there's a lot of first order theories, and people tend to think of higher order theories as just another kind of theory that you add to the list. But I think that instead we should think of them as a class of theories. Just like there's many kinds of higher first order theories, there's so also going to be many kinds of higher order theories. Coincidentally enough, since we're all mentioning our books here, I will mention that I do have a book coming out on this where it's due out in April, where I try to say what the various kinds of higher order theories are, what might count as empirical evidence for against the different kinds that there are out there, and classify them and think about them in a kind of orderly way. I'm not going to be doing that today, but I do want to focus on two versions of the higher order theory in particular, because these are the really cognitive versions of the theory. So if any version of this theory we're going to be challenged by Ned's work, it would be these kinds of theories. So in particular, I want to talk about the higher order thought theory, which has been championed by David Rosenthal and others. And then also a version of the theory that I had developed that I called the higher order representation of a representation, or the horror theory. So these theories are related to each other, but they are also different from each other. And I think that Ned's challenge gives us a way to differentiate the theories and see that they make different commitments, so that each version of the theory will respond in a different way. So, and that's good, because even though these theories are very similar, there are ways to empirically differentiate them. So what I want to do then is say a little bit, give a caricature of the higher order thought theory and contrast it with what the other versions of this theory might say. So now you get to see my PowerPoint slides as conceptual art segment of the talk. So if we imagine that the world has certain properties, we could call these properties, here we have the property R, we might call it a perceptible property, because we might imagine that in the mind of some organism, there comes to be states which allow that organism to be responsive to the perceptible property. So in the typical case, this might involve some kind of conceptualization of the property in the external environment, as well as maybe some non-conceptual component like a mental quality. We could think of this as what in the higher order theory business we would call the first order state, because it is an awareness of the external property. So what you're aware of is something in the external environment. So these kind of states have their causal effect due to their connections to other such first order states. And according to the theory, at least in the limits, one thinks one could have a bunch of these kind of states generating some pretty interesting behavior, even though there was no conscious experience. In order to have conscious experience on the view, you need a kind of higher order awareness, which the higher order thought theory sees as a kind of thought, something to the effect that I am seeing red, where something more specific along the lines might be I'm in a red star state, where red star is the mental quality that the first order state has. So at that point, there's something that is like for you, and you come to see red. Now, at this point, we could think about Ned's challenge, and we might think to ourselves, well, what is it that he's actually arguing for? Well, he's arguing for color perception in the absence of concepts, but what kind of concepts? So one thing that the higher order theorists might point out is that plausibly what's missing in this case is the concept of the external environmental property of the surface. But according to the higher order thought theory, the concept that applies in the higher order thought is the concept of mental red. It's the concept of something which is mental, not something which is in the environment. So one response you could have is simply to say, well, you could take Ned's evidence at face value and say, look, what these experiments show is that these infants don't have the concept of the perceptible property, but maybe they acquire this concept, which figures in the higher order thought in another way. And in fact, that is sort of what I think the view here is, that maybe early on in infancy, they are having all sorts of sensory states. Maybe they're comparing them and wondering whether or not they go together or not, in which case they might easily get the kind of concepts that would figure in these kind of higher order thoughts. So I think that is one possibility here. The other possibility is that you could argue, well, look, in this range, there just are no higher thoughts, so that the higher thought theory predicts that the infants are just not conscious, even though they do behave and respond in the various way. So I do think that there's a bit of a tension here for the higher order thought theory. It'd be interesting to hear proponents of that view, what they think of it. Because on one hand, we have, I think, the kind of argument which we see in various places in David's writing, in David Rosenthal's writing, where he wants to suggest that these kind of concepts could be had early on, very, very early in the perceptual workings of infants. Now, how early is not exactly clear. But on the other hand, there's a background theory about intentionality, which is at work here, which sees it as a product of a kind of holism, whereby the thought, I am seeing red, is going to have its content, its meaning, its reference determined by the relationships that that thought has to all other kinds of thoughts of that nature, as well as to utterances, which one might use to express it. And this is not something just as a matter of empirical fact. I think that there's going to be a period of time in the infant's early development when they just do not have this capacity. And therefore, the higher order thought theory is committed to, at some point in the infant's development, they're not having any higher thoughts and therefore no conscious experience. Now, whether you think that's a problem or not depends on how early you think consciousness emerges, which, as we've seen, has been a subject of a lot of debate at this conference. So some people may like this more than others. On the other hand, the theory kind of does predict that you would have the same kind of behavior even without consciousness. So I think that one thing you could say is, look, they do have the concepts, they have the experience, they're just a different kind of concept than the one Block is talking about. On the other hand, you might say, well, look, maybe they don't have conscious color experience, at which point Block says, well, this is problematic because we have some indirect evidence that they're conscious. The indirect evidence being the kind of behavior that they present, which we just went over. And we don't see that really occurring in blind sight and other related examples. And I do think that it's obvious that we don't have any kind of actual experiments that present the kind of data that Block is looking for, that you get bored, look away, and those kinds of things. But we do see a kind of general trend in discussions of blind sight that the stimulus does affect the reaction times of the subject. They can become quicker. We have evidence where they pair them at the same time, and there can be distractors. So that there is a kind of adaptation or response in terms of neural terms to the stimulus. And that's not exactly the same thing, and I acknowledge that. But the evidence is indirect here. And if you pair that with, just as we were saying a second ago, Bob's in the audience here, so this is Bob's work about bottom-up attention in blind sight, does suggest maybe you could have unconscious control of attention. Maybe there's even some evidence for unconscious pop-out. This is from a different paradigm, continuous flash suppression, so we could argue about that. But I do think it's kind of just turns this into an empirical question about, like, at what age do you expect these kind of behaviors, and do they have the relevant higher order states that are posited by the theory, and how serious do we want to take all this stuff, so that if one kind of independently had reasons for thinking it occurred at a certain point, then you might have some reason to doubt the higher order theory. But you're already a long way away from Ned's challenge at that point. You're already well downstream from the sort of data presented in the cases that he appeals to. So I think that the higher order thought theory, either way you go, kind of lives to fight another day. Now, on the other hand, I also tend to think there's another way that you can go here, which would be more in line with the way I think about the higher order theory, which is to allow that the infants are phenomenally conscious, but to insist that maybe their consciousness is not like ours. And I think that that's kind of an assumption that's in Ned's work. We just heard some people talking about that just a second ago. But just to give you a brief kind of idea of the way I think about the higher order theory, which is somewhat similar, but I think different as well. So I can agree with, I don't really want to fight about the first order states here. I think there's going to be some states that allow the organism to be informationally responsive to the environment. I think maybe those could be the globally broadcast states. They might be the integrated states. They might be the local recurrent states. I think we could debate about that. But according to my view, to have the conscious experience, you have to have the higher order state, which represents you as being in the first order state in a way that I think of as like a complex demonstrative. So in something similar to the way when you say that dog is vicious, and that in there picks out some animal in the environment, and then you characterize it as a vicious dog. So there's a kind of demonstrative element and then a kind of characterization of the demonstrated thing. So I don't really think of the higher order states as being akin to ordinary thoughts. I think of them as representations I don't think of them as the kind of thoughts that you could think, which I think is a big difference between David and I. I also think that the arrow, which I have pointed up in here, is going to play a psychological role in the mind of the organism. So it's going to allow the first order state to become globally broadcast or be held in the global playground sense for further broadcasting or sensory processing, et cetera. So I think it's going to have causal effects, which we could test for. So that the arrow is a real psychological phenomenon. And then finally, I also think that the concept that's involved here is the concept of the perceptible red, not mental red. I actually am very skeptical that we have concepts of mental red, which the higher order thought theory suggests that we do. So there are all these differences which occur. But we, of course, the overlap is that we agree that if there's conscious experience, then there's going to be these kind of conceptual representations. So as I view it, then the assumption that's underlying Block's work is that the infants are going to have the same kind of color experiences that we do. But if you take the higher order perspective, and in particular, you take the point of view I have, which is that you could have a mismatch between levels of content. And instead of thinking that as an objection to the theory, I think of it as an empirical prediction that the theory makes. So something surprising that we could look for. Well, this kind of straightforwardly follows that if the higher order state determines what it's like for you and it can misrepresent the first order state, then you can have cases where those two come apart, where you may be in a first order state representing red and in a higher order state that's representing it in a different way. And in fact, that's what I think is happening in these infant cases. So if you show the infant something red, it may go into the red star state, have no concept, and then it may simply, the higher order awareness that shows up may simply represent you as seeing a dark square or a colored square or an opaque square. So there are many other kinds of concepts that are more generic related to color, which don't involve being red or green. And at this point, the theory says, well, you have phenomenal consciousness. It's non-conceptual in the way that Block stipulates, because the red star state is not being conceptualized in a way that would describe it. It's being conceptualized as simply in an incorrect way. So I do think that that's kind of qualifies it in the sense that's relevant here. And it would explain what's going on. On the other hand, if you present them the green case, they may represent that state in a very similar way, simply as there's another dark square, at which point, even if there were differences in the first order states, they may not be characterizing them at the higher order level, so that if they were both there, indeed, you may have this difference. So I think that the upshot of all this is that if you grant Ned pretty much everything in his interpretation, you still get an explanation of the data without a challenge, because these infants could be trained to notice maybe there's some subtle difference in the conceptual content. Maybe they acquire the concept in that way. But even if they have phenomenally conscious experiences, and even if the kind of thing which they're aware of is non-conceptual, it doesn't falsify the theory. And I just want to end by pointing out that this is kind of giving as much to Ned as I think you can, namely that these are conscious and that they're conceptual, but just withholding one thing, which is that the concepts deployed are like red or blue or green in the ordinary way. And of course, I think, as I just said, you could argue that they do have these concepts and just don't use them to form expectations. I don't think that there's a lot of strong evidence. There's a lot of indirect evidence about that, but I think you could debate that there. So that my strategy was really try to give as much as possible to Ned and to point out that we have these different versions of higher order theory that respond in these different ways. One of them suggesting that we would find certain kinds of higher order states with one kind of conceptual representation. The other one suggesting a different kind. But that while it opens up interesting questions, it doesn't establish that the theories are wrong and leaves much more for future investigation. All right, thank you.
Thank you very much. So I don't know anything about consciousness or the higher order theories, but I literally don't understand your proposal. So the question is, what is the status of this is me looking at a red thing? That sounds like you need a concept of me, which children don't have till, what concept of self do you need for that? And then the other one that you had two different glosses. This is me looking at, and the other one is this experience refers to a property of that thing or something like that. That requires the concept of an experience, an abstract concept of experience. So I mean, this is not a challenge. This is I just don't understand what the status. I can't understand the theory because I don't understand what that line is up there. Can you
Yeah.
talk more about it?
That's a good question. I mean, and I didn't have time to talk a lot about this, but I did kind of try to drop the me out when I was talking about the infants. So I do think it's an open possibility. I mean, it's just something, another place where higher order theorists will disagree. But I do think it's an open possibility that you could have the higher order states that just represent that there's a seeing going on, but not that it's you who's doing the seeing. And I do find that
Probably not a concept that kids have either. Babies.
well, it's not clear that they do or don't have it. So it seems to me that it's an open possibility that they could have it. We don't have any evidence against it. And the evidence that we're talking about here doesn't suggest that they don't. So I'm more just suggesting a way of interpreting the evidence that is consistent with the theory, which would suggest that we'd want to look to see whether they do in fact have these sorts of things. But I agree that if we found out that they didn't have these kinds of things at all, then that would be very troubling for the kind of view I'm suggesting. But the self concept, though, I do think that, so some people think that you need to have the self involved in order to count how you're aware of some specific kind of content. I do kind of want to challenge that. I do think that if you just have the kind of demonstrative component saying that's the seeing of red, that's good enough to count as being aware of the first order state, so that you don't need those problematic concepts until they show up later. That's how I'd explain the self-con. With the other ones, I think that we don't know if they have them or not.
Yeah, so that was it was a great talk, and there's a lot.
You sound surprised, Ned.
I disagree. I disagree with a lot of things, but so in the first version of the what you call the higher order thought theory, you said that they could handle this one of two ways. One is that the kids have a concept of what you called red star, I think. Or,
Yeah.
So the idea is the red star means the experience you have when you see red. So this strikes me as a really lunatic proposal. I mean, honestly, they have the concept of red star and they don't have the concept of red.
Yeah.
I mean, what in the world?
Well, I mean, there's a lot that
red star means the experience I have when I see red.
Well, it's
I
not an
don't know how-
experience that you have.
What?
It's the state that you're in when you see red, or it's the seeing of red.
I think the likelihood that they have a concept of their own experience of that sort. Anyway, I'm just going.
I mean, I think the argument. I
I'm
mean, David's here, so
expressing-
he can talk for himself. But I think that the argument hinges on the fact that infants will be doing cross-modal comparisons. I know that there's some work that says they do this at like 3 weeks old, where they're like, just a simple example of you hear a sound, so you turn your their head. So you're associating the sound.
Cross-modal things for color.
Yeah,
There's one modality in
color, yeah. Yeah.
Right. But you still want to know whether you want to pair it up with something like if something's red, is it sweet or is it bitter or is it going to be hot or cold? So there's lots of other things that you'd want to pair it up with.
Okay.
I think that opens up, it's an empirical challenge. I'm happy to see the higher order thought theory challenge. It's not my favorite way of thinking about things. I just think that this would be a way that you could try to empirically challenge the view by suggesting that either they do or don't acquire these kinds of concepts. But it's an open possibility, which isn't ruled out by the evidence you presented. Which was
Okay. The second thing is, are these infants conscious?
Yes.
And that I think is a serious independent thing. So I presented a few things that sort of slightly indicate that they are. The one is the strange colors. They don't like to look at the strange colors.
Yeah.
Seems like intuitively kind of a conscious reflecting some kind of negative experience when you look at the strange colors. But then, just moving your eyes to a thing of a different color, I don't know if people do that in unconscious perception. I'd be curious to know about that. And what about habituation and real habituation,
Right.
and unconscious perception? Does that happen? So,
I mean, I think it's, first of all, just note that it's odd that you're appealing to the intuition. When I heard you earlier, I thought rightfully suggesting we should stay away from those kinds of intuitions in this kind of case. So I do think that we want more than the intuitive here. And so, well, we could circle around it. So I think that's exactly the kind of thing which this discussion opens up, is that there's a lot of empirical questions that might be tractable that if we had the answers to, would weaken or strengthen our credence in these other kinds of claims. So that I think that that's what's interesting about this, but that it doesn't on its own. All it does on its own is suggest, if you knew this, then you would know something else as well. And saying intuitively, it seems like that to me. is I want more than that. But I agree that those are the kinds of questions we want answers to.
Questions we can answer to be 4 questions.
Yes. So your account made a lot of sense, I believe, actually, in light of the distinction that we often have between, like, say, detection and discrimination, for instance. So it might be that infants are, and probably they are detecting, they know that they're seeing something colored, but they just can't discriminate which color it is. They can't, they don't reach that level yet.
Right.
But you don't need to instantiate like 2 very different levels of, like, 2 types of consciousness involved here, but you just need to account for the fact that they have consciousness at a certain level, which is the level of seeing that there is an object with a certain property,
right?
But the inability to reach a higher level where basically they know to distinguish that from another instance, for instance.
Right.
So this could be operationally very well explained. I think you explained very well, and it makes a lot of sense. It doesn't need to instantiate like 2 different types of experiences, I believe. So for me, it makes a lot of sense.
Nice. Do you hear that, Ned?
Andrew.
Okay, so I just want to understand the positive proposal better and ask if there's any independent reason to believe it other than it explains this particular case. So is the positive proposal just that you do have a higher order representation? It's just a misrepresentation of what's going on in the first order state?
Yeah.
So I understand the dialectical move because you want to show that this state is compatible with this set of empirical data. So you can always make a theory compatible with a set of empirical data by adding on an auxiliary hypothesis.
Yeah.
But then the question is there any other reason to have that hypothesis? So I was just curious as to whether there was independent motivation for the addition.
Yeah, no, I agree with you. So my goal was really just to show that there's an interpretation which is consistent with all the data, but doesn't falsify the theory, but then also opens up areas where you'd go, we'd want to know more about that area in order to really make an informed decision here. So it was really more of like an advertisement that this is a cool place to look for further kind of data that we don't have yet. And now we can see that this theory does make actually fine-grained prediction about what you would expect. So I didn't really have independent reason, except the kind of intuitive idea that it just seems like they would be thinking about these things at some point, at some low level. So you would kind of expect it. And then fitting with what Sid was saying, that it makes sense in terms of some other things that we think about discrimination and detection. So that it's just kind of vague, intuitive stuff, but then use it as a springboard to look for more empirical details. And then to show that, well, this by itself doesn't refute the theory, but it certainly does open a doorway into an area where we'd like to know more. And that's what I appreciate about it.
Thank you so much. This is really interesting. Very quick question. So suppose I buy the star thing for visual perception, and I have this like state of like seeing with no point of view. What would be the equivalent of exactly the same thing for different modalities, like for instance, like touch? So what is the star
equivalent in a different modality of seeing without a point of view?
Yeah. So for instance, like can you conceive like tactile perception without point of view?
Yeah. So I do think that maybe you could think about cases like somatoparaphrenia and other such cases where people will deny being touched on a certain body part, like an arm or something like that. But then if you say, I'm touching your cousin's or nephew's arm, they'll say, oh yeah, I felt it. So you could, well, they'll say it was felt by the cousin or something. They'll deny that they felt it. So I do think that there are ways of interpreting those kinds of cases that don't go in the way I suggested. But there's also a way of interpreting it whereby they have the conscious experience that they think of as someone else's, or that they experience as someone else's. And so rubber hand illusion is another kind of case I could think of where possibly something like this could show up. So I think that there are kinds of cases that can be interpreted that way. I just don't think that we know enough to say definitively what's going on in those cases. I just think that suggestively you can think of it in that kind of way as being a kind of analog. But someone else could think of it in a different way, and then it becomes, what differentiates them.
Hi, Richard. Thank you for the talk. I'm curious what your horror theory and some of these psychological notions that you're proposing mean for the neural correlates of where this might happen. And of course, this has implication for the developing infant brain. This suggestion about conceptual representations being a re-representation that then renders some first-order representation conscious makes me think that this could happen in sensory cortices, right? Even at the most amodal representations, it might happen in, say, temporal pole, right? So where does something like the prefrontal cortex factor into this? Is this position still something that, the prefrontal cortex is important for? Or can you get that just from, higher order multisensory regions or amodal regions, which are, at the farthest extent, right? You could even think about categorical perception of a table rather than a chair, or of syllables and so on. This is usually at the apex or included in some sensory pathway. Yeah,
that's a good question. I do think that there's a kind of tendency in the literature to kind of assimilate higher order theories to prefrontal theories, largely because some people that are associated with the former have endorsed the latter, hesitantly. But I think that people tend to over-identify those theories. So I think, in my opinion, these are psychological level concepts, inner awareness, first order perceptions, and we don't have a clear understanding of where we would expect to find those. So for example, I think of the global workspace theory as a possible candidate for what the first order states might be, the ones of which we become aware, in which case maybe first order states are in the prefrontal cortex. Maybe they aren't. So it's an empirical question. If we become aware of our mental states, where are the states of which we become aware? So I think that we're in an early stage right now. And when it comes to the higher order awareness, then it depends a lot how you think about it. So a lot of people want to think of this as a kind of metacognition or akin to it, or sharing the neural machinery of metacognition, in which case you might look in the prefrontal cortex. Other people think of it as a kind of self-consciousness, a kind of self-awareness, in which case you would expect different areas to be involved, not necessarily prefrontal, more parietal and medial as opposed to dorsal. So other people see it as a kind of non-conceptual awareness, in which case maybe you would find it in the sensory cortices. So I really think that we are at the lowest level of trying to link the psychological concepts to the neurological. And we have some good guesses, and I think they're worth following up. But I don't think that the higher order theory commits you to any one of these things. What it commits you to is the idea that inner awareness plays some important role. And then you have to go on from there and say, where would you expect to find that? So I think it's reasonable to look in the prefrontal cortex, but I don't think that's because the higher order theory dictates that. I think that's because I'm sort of convinced loosely by some other evidence that the prefrontal cortex is a likely candidate. But if it wasn't, then it wouldn't falsify the theoretical approach. It would falsify some specific version of the theory that postulated implementation in that way. So,
no back part. Sorry.
All right. I'll talk afterwards. Yeah.
Yeah. So last question from Jake.
Yeah. Thanks for the talk. Interesting. So one thing I'm wondering is that there's a persistent thread in the worries that, the second order content, the higher order content is over intellectualized, right? That it's too conceptual for infants to have, right? And so you said, well, you could get progressively simpler. You could even have just like a demonstrative thing like that thing is red or something like that, right? Uh-huh. But even that, which is I think the most minimal conceptual kind of account that you give, requires a grasp of quantification, because it's that, right? And so you're quantifying. And so if you need a conceptual grasp of quantification, that emerges quite late and will not probably explain the color, like the non-conceptual color data or something like that, I think. Uh-huh. So, how do you answer that?
Yeah, I think that's a good point. As far as like the quantification goes, that part, I think you can model it in many different ways. My own way of thinking about it is to think about it like an HTML address in coding, whereby you have some bit of code that introduces what you're going to do, like the hypertext protocol transfer. And then you insert the address, and the address is like literally the place where you'll find the state that's being referred to. And that's the way I think of the demonstrative element in the higher order state, so that it kind of lists as an address the state where it's describing. In other words, it's like the state of this address can be described in the following way. So that I think that you don't really need to have a full conceptualized notion of generalization or existential import or anything like that that you might get in for sort of formal logic. You get something much more lower level than that. But I do think later it does develop into something that's more quantificational, but not at this stage.
Okay, thanks so much for the introduction, and I really appreciate all the organizing this, amazing event. So I really appreciate it. So today I'm talking about our ongoing project about the children's color experience and its, comparison to adults. So this study is not about infant or fetus, but I hope this kind of research contribute to your understanding of the origin or development of consciousness experience. So doesn't work.
The arrows work.
Yeah, what? Doesn't work. Okay, sorry. So my research interest is to examine whether children's experience or qualitative aspect of consciousness are similar to or different from adults. So if you think about it, if you see a red apple, you may experience the redness of red, right? And my question is whether children who have a different brain and who have a different visual system have a similar kind of experience of redness of red. But as you know, it's very difficult to characterize people's experience even in adults, right? So, and children have the immature language skill and introspection. So, second question is to examine how to characterize children's experience without language and introspection. So in this study, we use a structural approach to address this issue. I think structural approach is discussed a little bit in yesterday, I guess. But structural approach allows us to examine relationship between experience. So, for example, we do have some structure of color experience. If redness of red is similar to pinkness of pink, but very different from the blueness of blue, right? So we do have some kind of structure of color experience. So qualia, which is difficult to characterize in isolation, can be characterized and compared through the relationship with other qualia. That's our strategy. But as you know, this kind of relational structure or similarity structure have been discussed a lot in the previous adult literature. Actually, there's a controversy regarding this kind of issue, but as far as I know, few research examine this kind of issue in young children. So in this study, we focus on the children's perceptual structure of color experience using psychophysics experiment. So we compare the structure of color experience between children and adults. Here's our assumption. So we adults, we do have some structure of color experience. So my question is whether or not children have similar kind of structure of color experience. So based on the discussion, before, children do, very have difficulty to acquire the, color language or color concept, right? So we assume that the children's experience or color qualia can be less structuralized compared to adults. So we test this assumption in this study using 4 experiments. So this is we call the qualia structure approach. This study is collaborated with Nao Tsuchiya Monash University. And this is our approach. It's also actually difficult, but first we gave children psychophysics experiment. Children are presented with a color pair, like red and green, and the children are asked to judge the similarity between 2 colors, like similar or dissimilar. 3 to 12, actually. And based on children's responses, we can create a dissimilarity matrix. Sorry. So this is a dissimilarity matrix. So for example, this is a relationship between red and red. So it's the same. So children should respond, very similar, right? So similarity is represented as a like white color in this dissimilarity matrix. And but red and blue should be very dissimilar, right? So such kind of pair is represented in the more dark color in this structure. This is matrix. And we visualize such kind of dissimilarity matrix using multidimensional scaling. These kind of color map, color structure is created. So this kind of structure can represent children's structure of color experience, we believe. So we can create this kind of structure between different age group, like younger kids or older kids and adults. So we can directly compare the structure between children and adults, which is our strategy. So we also compare children in different culture. In this case, we compare the Japanese and the Chinese kids in this study. And a strong point in this study is we use a smartphone to conduct this experiment, and which is conducted online. Actually, there are several problems of the color experiment in online. I understand it, but we address this issue later. So this is our approach. So in first experiment, we conducted a PC online, and the Japanese 5 to 12-year-old participated, and adults also participated. And experiment 2 and 3, we use touch panel device, especially smartphone online. And the Japanese preschool kids and the Chinese kids participated. In this study, we use 9 distinct colors, like red, orange, green, blue, purple, something like that. So there are 9 colors, so we do have a 9 by 9, 81 trials. But we conducted 2 sequences of 81 trials, so 81 trial and 81 trial, to assess the reliability of children's response. Because children's response are sometimes like messy, right? If they are tired, they are like this very randomly choose the option. So we'd like to address their reliability of their responses. So totally, children receive 162 trials. This is a demonstration of our experiment. So children are presented with a 2 color patch and asked to evaluate the similarity in 4-point scale. So very dissimilar, slightly dissimilar, slightly similar, or very similar. So children presented this kind of experiment. So young kids took 20 minutes to complete this experiment, and the adults took just 10 minutes to complete this experiment. First, I report the reliability of children's response. So y-axis represents the correlation between 2 sequences. So correlation coefficient is the y-axis, and x-axis represents the age of the children. So as you see, adults show the most reliable response, which is not surprising, right? But even 3 or 4-year kids show the reliable response in this study. Children's correlation coefficient between 2 sequences increase as a function of age. But some kids are excluded from the analysis because their response are not reliable. Our criterion is 0.3, so which is a kind of significant criterion. So we excluded 23 3 or 4-year kids and 13, 5, 6-year-old kids excluded from the analysis. So this is one of the main results of in this study. This is a result of experiment 1, 2, and 3. This each this mathematics represent children in different age group. So as you see, results are kind of very similar across different age group, right? So for example, this here is like a cluster of the green like color, and here is a cluster of blue like color. So these are kind of cluster are observed in different age groups, even 3 and 4-year-old kids. But as you see, there are some differences in the like this area. So adults show the more clearly distinguish similar or different color, but the young kids are relatively blur between the such kind of color. So for example, this region is really black, but this region is slightly less clear. So these kind of results are observed, but generally results are really similar across different age groups. The correlation coefficient is really high, about 0.9. So across age group level correlation with adult were really high in this study. So we visualize this symmetry matrix using MDS, and each point represents each color experience, like red, pink, like purple, and the nearer color represents a similar color, right? So, for example, this red and pink is very similar, but the red and blue is very dissimilar. And each symbol represents a different group. So, for example, this square represents 5 or 6-year-old kids in experiment 2, and this triangle represents 7 to 9-year-old kids in experiment 1. But as you see, generally, results are similar across age group, right? So, according to our result, color code structure was generally matched across different age group and different device. So PC and smartphone doesn't matter, and Japanese, Chinese doesn't matter. So general results are matched across different groups. But this is an online experiment, so reviewer said that we have to replicate this result in an in-person experiment. So we conducted, in-person experiment in university. So we recruit kids into the laboratory and using the same smartphone, the same luminance condition, and we measure the color coordinate using colorimeter, and conducted the experiment for the preschool kids and adults. But the result was same. So as you see, this is a symbol of the in-person experiment of adults and the kids, but maybe you cannot tell which is, where is the in-person experiment, right? So even though we conducted in-person or online experiment, so such kind of, in-person online experiment doesn't matter. So results are quite similar across different age groups. But this is a group level analysis. So we conducted individual level analysis. It's a little bit complicated, but we calculated individual correlation coefficient with adults. For example, each child have its own dissimilatory matrix like this, so which is very different from average level dissimilatory matrix, right? And we calculated correlation all adults between each child and all adults dissimilatory matrix. So we can calculate the correlation for each child, average the correlation coefficient, and plot the result into this figure. And actually, y-axis is transformed. So number is not important, but as you see, at the individual level, there are some age effect of the similarity with correlation coefficient with adults. Finally, we calculated which color pair differ as a function of age, and we found an interesting result. First, we actually found 2 categories, far category and near category. Far category represents in this color matrix, color structure, red and blue is far in this color circle. So in this far color, if you are present with the red and blue, maybe you may respond very dissimilar, right? But somehow young children showed slightly similar compared to adults. But interestingly, when presented with a near color pair, like red and pink, red and orange, maybe we adults responded very similar, right? But the children showed opposite pattern. So when children are presented with this near color pair, they responded slightly dissimilar compared to adults, like this. So this is a summary of this analysis. So blue arrow represent far color pair where children responded similar compared to adult. But the red color pair, red arrow represent color pair where children responded relatively dissimilar compared to adult. Actually, we don't have a good explanation for this result, but one possibility is something like this. Perhaps we don't have time, so I'll skip this. So to summarize, color qualia structure quite similar across age group and culture and device or experiment type. But we found the age-related differences in the evaluation of the same color pair, so implying subtle changes in structure behind the color experience. But you may think that this is only 9 distinct colors, so it's very easy to discriminate the color, right? So we are now starting a new project about this kind of to address this kind of issue. One ongoing project is cross-cultural comparison. We found that the Japanese, Chinese kids showed very similar responses, but Japan, China has a very similar color term, so which is not surprising, right? So we would like to compare different culture with different color term. Also, 9 color is very easily discriminate. So we are now starting to use 93 color, which is more nuanced color. So if we use this kind of color, maybe we can get another kind of result of different from our study. Also, as discussed in the previous session, we are interested in the relationship between this kind of perceptual structure or linguistic structure or conceptual structure. So children acquire color term during 2-year-old age. So we are interested in the relationship between more perceptual aspect of the conceptual aspect. So this is our study. And finally, can I announce our project? Actually, we are in Japan. We are now starting a project about the qualitative aspect of consciousness. And in this summer, which is actually held on the October, but summer school, we do have a summer school of consciousness with Professor Tononi and Professor Koch in Italy. So if you are a student or postdoc or young researcher interested in this kind of event, please apply. Actually, I'm not going for the reason, but we do have organized this kind of event. So thank you so much.
Hi, very interesting. I think this is fascinating to use MDS to look at the structure of qualias. I was just wondering in your study, when you're doing the comparison between infants kids and adults, how much can you account for shifts in criterion? So the fact that some of the kids might be just a little bit more liberal or actually more conservative, saying that it's more dissimilar than adults. And then maybe you would need to basically show that this is specific to colors and not to other forms, for instance, or like if you did another manipulation.
Yeah, sorry, so can you repeat the final part again?
So the final part is that maybe you would need a baseline to demonstrate that there's no shift in criterion, because if you ask them to do the same thing, not for colors, but for, say, shapes, for instance, shapes that are similar or dissimilar, maybe you would find exactly the same difference.
I understand, but based on the discussion in the previous talk, maybe shape is more easy, right? Maybe I don't know, but of course, thanks for suggestion. I should address. Thanks.
So thanks. I have a question about what you were saying about sort of similarity, structural similarity, and I just wanted to hear your thought about, is it the idea that the approximate similarity that gets closer and closer, is it structural similarity like on all points, or would it make sense to say maybe there's a dimension where there's radical dissimilarity and then very close similarity, like so saturation or something like that, right? So if you could.
But in this study, we just conducted a correlation between the dissimilarity matrix. So generally, the analysis is at this point is how correlation, how similar to this point to this, such kind of analysis. So but this is more very, very primitive analysis of the structure. So we are now thinking about using more advanced alignment technique. Actually, our colleague has conducted such kind of alignment technique, but this analysis need more color, like more than 20 or 30 colors. So we are now, so that's why we are now planning to use more color. So
Yeah, I was thinking that maybe when you saw the difference between far and near, it could be actually that there's some kind of dimension along which.
right. Yeah, thanks so much. Yeah.
Thanks for the talk. It was super interesting. My question is just, I guess, either a request for you to speculate or just tell me if there's, because it seems like this is still in the earlier goings and you have more studies to do and things like that. But so you say there are some subtle differences in the color qualia spaces between adults and children, right? And you kind of just leave it at that, right? I mean, do you have any inklings or ideas about what the difference might be? I mean, the most, or the cause of the differences. I mean, the most obvious distinction is going to be that like adults mastered color terms, right? But that maybe would have a larger effect or something like that. Because it's a pretty big change.
Yeah, that's the most important point in our project. Yeah, we haven't not a great idea, but maybe language development is one important causal, factor to facilitate this kind of development. Also, maybe cognitive capacity. I'm not sure, but not cognitive capacity. Yeah, language is one possible candidate. But do you have any possible factor?
It could also be perceptual, but a lot more.
Yeah, thanks. Yeah.
Quick question, just in the double pass, do you take into account how different, it's over here, how different the similarity?
Oh, sorry. Sorry.
So you have 4 categories, right? They can rate in 4 different ways. And in the double pass, are you only rating for the identical one, or are you also reflecting how different? So if I went from 1 to 4, how is that coded different than if I went from 2 to 3?
Yeah, so it's just a correlation between the, Actually, order of the stimuli is, fixed in the first sequence, the second sequence. We just calculate the, each, first trial or second trial, the, correspondence between the response between first sequence.
So you take into account the distance between the.
Yeah.
Okay. And can you normalize by observer? It's a little bit similar to a previous question, so that you can. It's a way in which you could take into account the variability of the response.
Exactly. Yeah. So we conducted some transformation of the normalized value. In the paper. Yeah.
So on the issue of why the children think that red and blue are more similar than the adults do, and the similar dissimilarity.
Yeah.
So you suggested maybe the language is playing a role where the adults are saying to themselves, well, that's red and that's blue, so they're really not at all similar. And the children don't have such a firm grasp of the of those linguistic color concepts. Okay, there is a simple test for this, and that is you give the adults a verbal shadowing task, and see what their similarity judgments or dissimilarity judgments are like when they are doing a verbal shadowing. This has been a really good technique. So this technique has been used there's been a lot of experiments on the issue of, in Europe, some languages make a distinction between light blue and dark blue.
Right. Yeah.
So Russian and
Japan
Greek make a distinction between light blue and dark blue, and many other languages like English do not make that distinction. And it's been a repeated result that if you give the subjects a verbal shadowing task while they're making their judgments, that difference goes away.
I see.
So it suggests that the perception is really the same, and that the cultural differences are just affecting the concepts. And you can get a line on that through verbal shadowing.
Right. Yeah. Thanks so much. Yeah. Actually, that's really amazing. Yeah. Research. Yeah. Proposal. Thanks. Yeah. We will. Actually, we cannot answer right now, but we can try to check the experience. Yeah. Thanks so much. Yeah. It's amazing.
I wasn't 100% clear on what conclusions you wanted to draw from these structural similarity facts. So, just say we discover that adults and kids or people in 2 different cultures have the same structural similarity matrix, it seems to me there's three different kinds of conclusions one might want to draw. One is that, same structure, same qualia. Then, of course, that's very, very controversial one philosophically, but that's one way to understand it. And another somewhat different claim is we're actually learning something about categorical perception, right? And color categories built into the perceptual level. You might think that similarity in different judgments reflect something about categorical perception. The third is that actually, no, it's not actually reflecting anything about the character of the experience or the perception. It's actually reflecting something about our concepts or perhaps even our language. So there's three or four different hypotheses there. And I'm wondering to what extent you want to commit yourself on any of them.
Yeah. That's the most difficult part, actually. We cannot tell three different possibilities in this experiment, but so I don't know. At least we can, that's the most actually limitation of this study, but actually we are not thinking, we do not have any good idea to tease apart three possibilities. So I want to have any suggestion for do you have any?
Categorical perception, I think, is in some ways an interesting intermediate one, at least to aim for, but that still would require saying that similarity judgments reflect underlying perceived categories.
Right, I see.
Always been complex.
I see.
So we have another question there. Then we'll come back. We will give it. Is in this point? Okay.
Okay, thank you so much for your presentation. I'm not a philosophy student or research, but I'm interested in your experiment. When you were selecting, so you were focusing on cross-cultural comparison of qualia. So you were selecting Japanese kids, Chinese kids. So that's based on your design of experiment to compare what different languages and cultural background could influence the children's reaction, correct?
Sorry, can you repeat the last part?
So that's part, that's the question. And also my question was, when you were designing that experiment from Japanese kids and Chinese kids. So those are the kids in Kyoto. So you're from Kyoto?
Actually, all over Japan. So
all over Japan.
Experiment, right?
Okay. Are those kids bilingual or only?
All right. Monolingual. Actually, monolingual kids in Japan.
Monolingual. So those Chinese kids, they don't speak Japanese at all.
Because Chinese kids in China.
In China. Okay. Yeah, that is my other question is, I feel I don't know Japanese, but I know Chinese and English. So my understanding that in different languages, for instance, in Chinese, the color vocabulary is, according to my understanding, is much less than in English. In English, we have different shades of color, quite more vocabulary, especially for colors.
Right.
So maybe you could include more Western culture,
of course,
languages, kids to compare these. So that would be very helpful. That's all.
Thanks
you.
so much. That's our we are planning to conduct. So, but Japanese, Chinese, English, and European languages generally similar, I guess. So I'd like to conduct more, population in specific color town. But thanks so much. Suggestion.
Yes, my question.
Final question, please.
My question is along the same lines. This is really interesting.
Thank you.
There is a beautiful line of work by somebody named Noga Zaslavsky on here at NYU. Yes, that's how I happen to know about this work. She does computational modeling from the point of view of information theory.
Right.
And she has systematic studies of what there are really huge cross-cultural differences in color categories, like how many they are and which ones they are and where they draw the boundaries. And she can model that in terms of the structure of the underlying innate color space and then various information theory statistics. But it would be, I highly recommend you read that paper, read her papers, but also study cultures that are in different places, in that category to address the kind of question that Dave asked.
Right. Thanks so much. Can you repeat her name again?
If you just send me an email,
Can I?
I'll send you her
Thanks so much. Yeah.
address.